Alright, I'm going to do a quick version of the golden rectangle because the first version I did of the golden rectangle was some 40 odd minutes, and I don't think anybody really wants to listen to me prattle on while I draw pictures or geometric figures for that long. Alright, so let's begin. Okay, this is the Vesica Piscis. Let's see here. Yippee skippy. Okay, so two circles that overlap, and they overlap by one radius. Okay? The one circle has a circumference, and the other circle has a center on that circumference, and that goes both ways. You could have drawn them one on top of the other. I like side by side. It creates a figure in the middle called the Mandorla, or Vesica Piscis, fish bladder, also known as a lens, or an almond shape, a pointed oval. If you like root words, oval simply means egg-shaped. Ova, ovum, egg. So it's an egg shape, a pointed egg shape, sort of like a football or a lens. Anyway, we're going to want to add some more circles. So here's an intersection point. We'll draw a circle centered there that is the same radius as the others, and its circumference will pass through the two radiuses, the two centers that we have already. We'll look at the next intersection point here, and that'll pass through the center points of two circles that are nearest it. And we'll put one here, and that'll do the same. We could keep going, but I'm not so interested in building up the shape from circles. I'm just interested in using the circles as a reference for building the shape that I want to make. So I'm going to take just a few more of these intersection points, and I'm going to put dots at them that makes it easier to grab them to do things. I'm going to create a line, construct a line. Let's say construct a line vertically down here. It takes 2 points to define a line. A line running through one point could go in any direction, but a line that's running through 2 points goes in one definite direction. And it can go as far as you want to in that direction. If you have a ruler, just slide the ruler on down and take 2 other points. Make sure that they're perfectly aligned, and presumably you can keep going indefinitely. We're going to do the same thing on the other side, and that really is the whole point of having the 3 circles at the bottom. And now that we've got that, we don't really need to see them anymore. All right. So, that's good, no? All right, we are going to note the intersections of the lines and the circle here and here, and we may as well note the intersections at the bottoms of the circles as well. Okay? Now, you'll note that the 2 blue dots here are separated by 1 radius. And if we take and go from those blue dots, you know what, I'm gonna start by minimizing my lines to some extent. So I'm going to minimize these lines. I'm going to lighten the lines. So we're just barely going to be able to see these. And that's going to be the same way with the circles. Alright, so we're going to do some connect the dots. So, before we do, we're going to look a little bit more closely at our circles and see how we're connecting our dots. So, with an arc centered here, starting at the point at the top of the circle that comes down there, that's 90 degrees. That is 1/4 of the way around the circle. If you divide the circle into 4 parts, and let's go ahead and do that right now, actually. Might as well do it because we're going to be doing it. So let's divide the circle into 4 parts. And now we can see that it is 1/4 of the way around the circle. that is a 90-degree angle. That is a perpendicular angle. Okay? So it's a 90-degree angle, and we can see that this top point is exactly as far from the center point of this circle as the point over here. So they're all exactly the same distance. That's kind of what a circle is, geometrically. It's a set of points that are all equally distant. So this line is a radius of this circle on this side, and this other line is also a radius. So they're both the same length. They are unit 1. Okay, let's do the same thing on the other side. So, centered here, starting here. Okay, let's try that again. I hit the oh, alright. I gotta move my figure down because I'm hitting my undo button. Okay, so starting here, here to there. Okay, so great. So we've got another 90 degrees of arc, which means that the distance across is exactly the same as the distance from this other blue dot to the point just above. Okay, and as these are both 90 degrees, this is also 1 unit. It sits between parallel lines, and it runs at exactly the same angle as the other one, the one at the bottom. Okay, so that is a square. That is a square. Logically, deductively, we have drawn a square. We are in the ideal realm now, my platonic friends. Okay, so we no longer need to see these arcs right now, and nothing depends upon them. Now, we have these other 2 dots. I'm going to go ahead and, well, you know what? I guess this is kind of a fork in the path. We could do this in a couple of different possible ways. We can connect these 2 dots, okay, and we have a line now that divides our square in half. Okay, it divides the entire figure in half. There's another way we could have done this. We could draw a line from this corner here, which would be like a second square below the one that we're doing up here. We're using the line that joins the 2 center points of these circles as a baseline. And we could just as well have used it as our roof, as our ceiling, or our roof as our base. So I'm going to take this dot down here, and I'm going to draw to the opposite side. Now, I've done other videos explaining that this length, in terms of our radius being unit 1, is the square root of 5. So you have to understand that makes this length half the square root of 5. And if this is 1, then that makes this 1/2. So if we put this length together with this length, then what we've got is 1 plus the square root of 5 over 2. 1 plus root 5 over 2. So half of 1 plus half of root 5. Same difference. Okay? So let's go ahead and we're going to add that line to this line. And the way we're going to do that is we're simply going to take this segment and we're going to sweep it down with a circle or with an arc. So place a center point right there. Put a circle with its circumference on the corner of your square. The intersection of the circle with that baseline. And that length that we have now is a special length that has a lot of significance to this this golden rectangle. This length is phi. Okay? Phi, which is approximately 1.618. And you can go on and on and on. Just like pi, it's an irrational number. It's a non-terminating, non-repeating decimal. It's less than 2, more than 1, more than 1.5. It is what it is. And it's a very significant number that'll recur to us many times. Anyway, now do you know how to draw a perpendicular line? We've done it already several times, and we can do it once more. So let's see, let's draw a line from here to here. Okay, and I'm going to take that right there, and we'll go ahead and we're going to draw another circle, a couple of circles, and those are going to enclose this. We're going to draw there, and that gives us our perpendicular. Okay, and we're going to extend this line, and where that line runs into the other one, and that's going to be kind of hard to hit, so I'm going to use my intersection tool. We're going to take this line plus the vertical line that we just did. There we go. Okay, great. Now we can hide this point and the other construction lines. I'm even going to go ahead and hide this one. We don't need this circle anymore. We don't need this circle. Well, that circle or this circle. There we go. We don't need this point or that point. We don't need this anymore. Okay, and we don't need that. Okay, super duper. Now, yeah, so that is our golden rectangle. Okay, and its length is 1 plus the square root of 5 over 2, and its height is 1. 1 by 5, or 1 over 5. That is our golden rectangle, and it's built up in terms of units, and it's pretty good. Okay, let's see here. Let's go ahead and I'm going to hide my square root of 5. I think I'm going to leave that up. Get rid of that one. I'm going to get rid of all these ones below. And let's see, we're going to draw a couple of lines across this. I'm going to get rid of, I'm going to get rid of this one. We don't need to see it right now. All right. Can move that a little bit. Sort of straighten it up, maybe. Okay, so our golden rectangle. One of the features of the golden rectangle is that it consists of a square, and when the square is divided from it, what you're left with is a second rectangle that has the exact same proportions. That is to say, the ratio of the length of one side to the length of the other side is the same as the ratio of the entire figure, with the square included. See, so what you have over here is you have one that's kind of on its side. So this is it on its side, and this is your square. And the ratio is such that that this long side of the entire figure corresponds to the long side of this smaller figure. And the short side of this smaller figure corresponds to the short side of this longer figure. And we're going to see this demonstrated. We're going to work this out. So, one way we can do that is I'm going to draw a diagonal from one corner to the opposite corner, and then we're going to do a perpendicular line. Let's see, I guess let's do this the hard way. So we're going to draw a circle from here, and we're going to draw that circle through the line. In fact, let's go ahead and just draw it to that point. And then we'll put another point over here. Okay, so now we have to draw a couple of overlapping circles. We did this to get a vertical in order to do the end of the golden rectangle, but I think it bears repeating at this point. So it doesn't matter exactly how big that is, you just have to make sure that it goes more than halfway. That's good enough, it can sit on that corner. I'm going to use the tool down here called the compass tool to make sure that we get an actual equal sized circle, and then we're going to connect the dots on that. We're going to draw from here to here a line, and that line will go through that corner. Okay? Now, we can now hide these from our view. Alright, and that one too, I guess. Alright, so we know that that goes through that corner. So it hits the corner of the square. So that's significant. I'm going to go ahead and just hide this one too, because now that we know that, we can just draw the diagonal from this point to this point. Okay, and that's going to be 90 degrees. And in fact, we're going to ask the program to verify that it is in fact exactly 90 degrees. Let's see here. We've got an angle measure. Here we go. So angle between this line and this line, 90 degrees. And you see it draws it as a square, so you know it's exactly 90 degrees. Sometimes when you're very close to 90 degrees, it'll read 90 degrees, but it'll show like a little arc. This one shows a square, so it's not close to 90 degrees, it's right on the nose. Alright, that's good enough for me now. Okay, also there is a shortcut. There is a perpendicular line in here, which I use quite often. Anyway, we're not doing that right now. So, we're going to note the intersection point with the side of the square here. And, in fact, I guess we are going to use the perpendicular line, because let's draw a perpendicular line from the square through there right now. And we're going to put another little dot right there. And then I will hide this line. And there's the little bit that we made. We cut off. Now it looks like the part that we cut off is also a square. So that's interesting. Do you think that's actually a square? I think it is. Let's see, maybe a quick way to verify a square. Well, what if we drew an X across the points? We noted the midpoint, and then we put a circle from there to one of the corners. And that circle runs through all four of those corners. So all four of those corners are equally distant. Okay, so that's one way of verifying a square. Can you think maybe of another way we could verify that this is a square? Maybe with an arc. So from this corner, we'll draw an arc from here to here. From this corner, we'll draw an arc from here to here, just like we made the square that we used to construct the golden rectangle. It all adds up. That's 90 degrees. Those are perpendicular lines. They're equally distant. Okay, so that's pretty good. We know pretty sure that that's a square. All right, so we've cut off a square in an extra little bit, and the extra little bit actually has the same proportions as the entire figure. And you can tell that because the same lines run through it, you know, and hit it in the same proportions. So if we take this point right here, and let's go ahead and we'll draw a perpendicular line through that point, and we'll take the point here, and then we'll just hide the line because that's just way too big. Okay, and whoops. Segment. So we'll draw one across there. All right, what have we got now? Have we got a square again? An extra little bit? It sure looks that way, doesn't it? Okay, let's keep going. Whoops. Okay, so let's take this point. And let's see, let's draw perpendicular. Whoops. Perpendicular. There. From there to there. Okay. Put a point right there. Okay. We can now hide our perpendicular line. We'll draw a segment across there. Looks like another square, but is it in fact? Let's keep going. Here. Perpendicular line. Point. Oh yeah, hide the perpendicular line, draw a segment. Looks like a square in an extra little bit. Do you think that's what it is? Maybe one more time. Point, perpendicular line, point, hide the line, segment. Looks like a square and an extra little bit. And in fact, you can keep going indefinitely. Now we got another trick. Let's go ahead and do this real quick. I'm almost at 20 minutes, so I don't want to take too long this time around. Where's my arc tool? Arc. There we go. Okay, so. Well, that's not the way I wanted it to go. There we go. Okay, I'm going to hide a few of these points. In fact, I'm going to need that one. Okay. Found another point that I need. All right, that's kind of interesting, don't you think? So we have a spiral here that kind of resembles a nautilus shell. Now I've looked at some great lectures on mathematics that say that this is not exactly the same size as a nautilus shell, but there you go. It does have a certain resemblance to it, doesn't it? And we made that from arcs. We made that from 90 degrees of arc, and each time we did 90 degrees, we moved the center point. We didn't move it smoothly, we moved it in jumps each time we reached 90 degrees, and yet the whole arc seems to flow together pretty darn well. Another feature about the arc is that the point where those two lines cross, which apparently relates to the way that we divided each of the squares. You know, we divided each part of the golden rectangle into a smaller golden rectangle by dividing a square out of it. Well, the place where those two lines cross, which is 90 degrees, you know, is also the point at which the spiral forever tends to without reaching. You could draw the arc within each square of the golden rectangle in different ways and come up with different patterns that look perhaps a little bit more like, oh, I don't know, an exotic shell with spikes, or perhaps a hand or knuckles or a scorpion's tail or something like that. But you know, this one's pretty good. All right, I don't want to go long, so I think I've probably covered about most of the good stuff about the golden rectangle, and we'll just stop right there. Over and out.